Thank you for coming to my talk this afternoon. Hopefully some of you are dealing with the siesta period a little better than I am. Coffee only helps so much. But today I'd like to talk about something I'm very passionate about, and that is testing, in particular about test doubles. Now, the name of my talk here, you probably know where this comes from. It comes from Wizard of Oz, Mox and Stubs and Spies, oh my. We're going to take a little journey down the yellow brick road to learn more about what test doubles are and kind of where they fit into the overall testing in Android. So, kicking things off, test doubles are kind of an umbrella term for a lot of different kinds of objects. We have things like dummies, mocks, stubs, spies, and fakes. So these are going to be the things that we're kind of focusing on throughout this next 40 minutes here. So I hope you guys get to learn about how these things fit into your tests, where you get to use them, and kind of those little differences here and there. Now, my talk about test doubles wouldn't be complete without talking about what kinds of tests you would be using them in, and that this gets to lead me to something I like, which is the test pyramid. Now, you could probably have an entire conference talk or several about the test pyramid and many more arguments online about whether it's valid or not. But this is what I'm going to be using for the talk here. So we have unit tests, which means you are testing one thing in isolation. So just testing that one thing, not how it interacts with other things. Your end-to-end tests up at the top are going to be testing your entire system. So you want to make sure everything works together as an entire unit. Integration tests sort of fit somewhere in the middle there. Maybe you're testing one particular subsystem of your application. So in Android, maybe you're only testing that the login flow for your app works correctly. You don't care about anything else. You just want to make sure that one chunk works properly. Now, it's a pyramid here because the end-to-end test up at the top is smaller, meaning you're going to typically have less end-to-end tests than unit tests. So typically you'll focus more on the bottom. The ones at the top are kind of a nice to have. So this leads me first off into when are you going to use test doubles in your applications? When are you going to use these in your tests? Well, there are three different cases here. So you will use them when your system has indirect inputs, they have indirect outputs, or you have slow tests. Now, if you can't tell already, I'm a big fan of diagrams, so there's going to be a lot of those here. So something a little bit more clear. So in this case, what I mean by indirect inputs is that you have some sort of system that you are testing, whether this be a flow through your application or a method that you are testing. Either way, you are providing some sort of dependency, maybe a parameter to a method or some kind of private member variable. But you aren't actually doing anything with that object. You are querying that for something else. In this case, I'm making some expensive query. Maybe I'm getting something from a database or something like that. But in this case, if that input is difficult to create, then your tests are going to be a little gross because you're going to have to kind of create that input object, set it up correctly. If that input has other dependencies, you have to create all of those, which can be very annoying. So we'll use test doubles to kind of get rid of that. Indirect outputs, on the other hand, are things where it's difficult to test, for instance, a method directly. So a lot of functions will have a return value, and that's good to test. You should have a test to make sure it returns the right thing. But in some cases here, you have this dependency which is handling some data. Now, this is kind of a side effect of this method, and without test doubles, it's very hard to kind of validate that. So we use test doubles for this as well. Slow tests. This is kind of like a secondary purpose of test doubles. This shouldn't be what you're striving for, but in some cases where, like in integration tests, if you are interfacing with a database or a network, you're typically going to want to separate that from your test layer because they're kind of flaky. Database reading is really slow, so it slows down your tests. So you can use test doubles to speed that process up. So we've got the three different tests we're going through. We've got kind of the purposes of test doubles, and we have those 5 test doubles I mentioned before. So I'm going to go through each of them in turn, kind of talk about what exactly they're for, and then what tests they actually apply to, because not all test doubles are used in each test type. So mocks are first. This is probably the most overused term with test doubles. If you've ever used any kind of mocking library, This is probably the one they talk about, unfortunately. Things get a little muddy here and there. So this leads me into what is a mock at kind of the definition level. A mock is an object that simply records what you do to it. So in this case, I have a mock object. It has a little log that it keeps. So if I call the method do something, pass in parameter A, it'll say, oh, hey, I'm just going to write that down. So do something A. If I say, hey, do something B, it will also record that. Now, a secondary purpose of mocks is also to return data. Now, this isn't like creating a lot of complex data in order to return. This is only returning enough data in order to keep your test going. Because in some cases, if the object didn't return anything, your method's going to not work because it doesn't know what to do. So you can return values from a mock object, but again, that's kind of a secondary purpose. Now, once your mock has this call log, what you do with it is you basically verify what was done to that mock object. So this kind of fits into that indirect outputs case. We would basically replace that dependency with a mock object and say, hey, inside of this method, I want to make sure that this particular method is called with this parameter so that I know that my system is functioning correctly. Now, inside of mocks, there are two sort of subtypes. Basically, this is how mean they are when you run your tests. You have a lenient mock, which, as its name implies, it's kind of laid back. If the calls are made like out of order in what you specify, doesn't really care. If you call a method it's not expecting, also doesn't care. Strict mocks, on the other hand, are the ones that will make your life kind of difficult because it will actually fail your test if the methods are called out of order, if you call something that it isn't expecting. So it kind of depends what you're testing in certain cases. Now, lenient mocks, I think, are a lot more common in this case. Usually, you don't want to be verifying like the exact method order that things are called in, because that can kind of lead to flaky tests, but I'll talk more about that in a little bit. So mock objects, again, they're good for that indirect outputs side of our test usage. So we have our test pyramid again. So with mocks, they do fit very well into our unit tests because, again, we are testing that a single object works by itself. We don't want it to be interacting with any other actual objects. So we would pass it mock objects to make sure that it functions correctly and it's calling the right methods through to its other dependencies. Now, same goes for integration tests here. You do have to be a little bit careful with integration tests. Again, my example of where we're testing a login flow for our application. You want everything in that login flow to be as realistic as possible. So you want all of your dependencies to be real. If you're using like dependency injection or anything, you want to inject the correct like login, store objects, and session things because you're actually testing everything works together. However, if there's like another system that your login flow interacts with, you might want to supply a mock object instead just to say, hey, my login system calls through to the proper method in that other system. Now, your end-to-end tests, on the other hand, this is where mocks aren't really coming into play. Again, your end-to-end tests are going to be kind of as close to realistic as possible because you're testing your app from end to end. So mocks aren't really good there. You're going to want, again, most of your real objects in that case, so try not to use mocks in your end-to-end tests. Next up is Stubs. This one, going back to the mocking libraries, is kind of the forgotten child of test doubles, unfortunately. So Stubs, on the other hand, they are the ones responsible for providing data to your application. So mocks are the ones that are like taking in those indirect outputs. Stubs are the ones handling the indirect inputs. So in my one case where I had that really complex method query or maybe a really complex object to create, you just replace that whole thing with a simple stub object and you say, hey, when you have this method called on you, just return this value. So when somebody does call that method, it's just going to pass that preset value back to the caller. Now, with Stubs, a big thing is that if somebody calls it and you didn't tell it what to respond, it's not going to know like what data to send back to the caller. Now, the actual functioning of this in whatever test library is kind of an implementation detail, how they want to do it. In some cases, it might throw some sort of stub exception, say, hey, you didn't tell me that this method was going to be called. Other cases, it might just return back whatever the default value is for that type. So like 0 for int, null for some other object. Now, like mocks, stubs also have their own subtypes. So you have the responder type, which is kind of like your happy path. So, hey, I had this method called, here's a valid result. So that's a lot of your tests. You're going to be basically testing the happy path. Say, hey, this happy thing happens. I want to make sure I'm getting back valid data. That's a responder. The saboteur, on the other hand, is kind of where you're trying to mess up your application. When you have a method call, it's going to return an error or some sort of exception. So this is good, say, if you want to make sure your app handles a 404 from some sort of server correctly, you'll create a saboteur stub to return that 404 and then verify that your app functions correctly when that data gets passed back. Last but not least is the temporary stub. This stub is not so much for testing, but it is more for test-driven development. So the responder and saboteur would go inside of your test directory in Android because you're only using them inside of your tests. Temporary stubs would go in your actual production code. This is usually if you're, again, doing test-driven development and you're trying to drive out some sort of feature, you would basically make a stub object to kind of pick apart what functionality you want, and then it would eventually get replaced by an actual implementation. So not so much for testing, but still good for test-driven development, which is a whole other conference talk. For your stubs, again, this is for our indirect inputs, and very similar to mocks, this is very good for your unit tests because, again, we're testing that one thing in isolation, so we want to have exact control over what information is getting passed to it. So we want to make sure that this thing responds correctly to the good inputs, it responds correctly to the exceptions that get thrown, and so forth. Same is true for your integration tests here. Again, stubbing out the boundaries there. So if you wanted to stub the database layer for your login flow for whatever reason, maybe return a access token instead of querying the database or reading from a file, you just provide a stub at that boundary point to return that data back. And again, for your end-to-end tests, not really going to want to use stubs here because you're basically removing a component of your application for that test, which makes it not really an end-to-end test. That gets more into integration testing territory. Now, Spies might be my favorite test double, just because the name is cool. So Spies are kind of a combination of mocks and stubs, but they also have another little tidbit about them that is pretty cool. So spy objects have a call log, just like mock objects. They're going to record every interaction that gets made with them. They also have that response list, so you can say, hey, when this method is called, return this value. The other thing they have is state access. So your spy object might be spying on an actual implementation of an object. So instead of completely replacing, say, like a session manager for a login flow, you can give it the actual implementation of the session manager, but you kind of wrap it with a spy. So it can see into the internal state of that object, but you'll still get all of this recording and responses. Now, with the responses there, if you do give it an actual object and you override a particular method call with a response, it'll just return whatever you specify. It won't actually call through to the method on that object. So spies, as they are combinations of mocks and stubs, you might be able to see where this diagram is going. Good for unit tests because you can both basically get the interactions with that object. You can also provide the indirect inputs for your other objects. Same goes for your integration tests. They're actually more useful for integration tests for the example I gave where you wrap a real object. So you can basically provide an actual implementation and then you can verify things are called on that object. And because of that, they're sort of okay for end-to-end cases. Not really made for the like providing data, but you can still verify that the right methods were called on an actual object implementation, and you can also verify the internal state, which you might want to do in an end-to-end test. Now, dummies are probably the meanest name for a test double, and they're probably the easiest to understand as well. So what is a dummy object? Well, to be honest, it doesn't really do anything. It's basically just there to fill the parameter list. So it's like, I don't know, kids who get picked last in the kickball game or something, they're just kind of there to fill the roster. Usually these are used when it's like, hey, I'm testing this particular method on this function, but the class needs this object in the constructor, but I'm not actually using it, so you just pass in a dummy object there. So again, you can actually create your object. So your dummy usage, good for unit tests, again, because, hey, I'm not testing this object in this particular method. Don't need it, just pass in a dummy. Integration tests are a little iffy on that point because you're testing how things work together. So I can see in some cases you might have a flow where this object needs this parameter, but in whatever I'm testing in this subsystem, it never gets used for whatever reason. So you might need a dummy in that case, but that will depend on your use cases. But not really good for your end-to-end test here either, because this is a full, again, system test. Last up, we have fakes. Now, fakes are an interesting kind of test double in that they don't really show up in a lot of libraries. Fakes are actual Java or Kotlin implementations of a particular object. Fakes sort of strive to replace a real implementation with one that's better suited for testing. So in this case, I have some object that can query data and store data, whether that be in a server somewhere, in a file, in a database, what have you. That's not the best for your tests because it's going to be kind of slow. And slow tests make people very sad when you have to wait on them and wait on continuous integration services and things like that. So your fake object will basically replace that real one with a implementation that is faster. So maybe it just has a in-memory implementation for you. So you're just saying, hey, throw it in a list when you store it, pull it out of the list when you query it. It just speeds things up a little bit. Now with your fakes, you're going to use these in a few places. They're going to be bad for your unit tests, shocking. But fakes in this case are, again, they're real implementation, which kind of defeats the purpose of a unit test. You're testing something by itself, so if you're passing it a real object, it's not really by itself. That gets kind of a little more into integration test territory. So keep your fakes away from your unit tests. Integration test, this is good. This is kind of where the database example comes into play. So if my login flow needs access to something in a database, maybe I don't want to wait on that database call in my espresso test, for instance. So I just pass in that in-memory implementation to make it faster for me. You can save a good amount of time if you have a very large test suite, not waiting for file I/O and things like that. Lastly, your end-to-end tests. I gave this one an okay. It might be in the maybe section. Really, it kind of depends how much fidelity you want in your tests. If you want it to be as close to your real app as possible, which you should be striving for in the end-to-end tests, you should probably just use the real implementation. Again, you're going to have the least amount of end-to-end tests, hopefully. So you might be okay waiting a little bit longer for those tests to run. But if you have a lot of them, maybe you can just swap out that one section. It's just good to kind of note this down somewhere, write some documentation, be like, hey, this isn't actually testing this part of our application. So maybe you go in and you add some specific integration tests for that functionality. Maybe you have some unit tests for that specific functionality. Basically, you just want everything to be covered in this case. And fakes can make your tests very quick to run, but they do open yourself up to a lot of danger because you're not actually testing what you might think you're testing. So I've gone through all of this and kind of talked about what all of these objects are. We've got our 5 different kind of test doubles: mocks, stubs, spies, dummies, and fakes. The reason I wanted to write or make this conference talk is because there's a lot of term confusion that goes around with these terms. And the reason for that is if you haven't learned these things in like a computer science course or anything like that, oftentimes you learn this terminology from different mocking libraries, and those aren't usually the best kind of enforcers of the theory here. So I'll kind of show you a little bit about that. So the mocking library I use, and probably most people use, is Mockito. There's also like PowerMock, EasyMock, probably like a dozen other mocking libraries out there, but the point should be about the same. So Mockito is probably the one to blame for overloading the term mocks for the most part. You'll see why. So Mockito does have mock objects, so you can say, hey, mock this particular class. It's also nice because it allows you to mock interfaces as well, so you don't actually need a concrete implementation. It'll just kind of build you out a fake version. And then you can add your verifications on your mock object. So again, it's going to have that little call log. It's going to record all the interactions and all the parameters that get passed in, so you can verify pretty much everything that gets sent to that object. It's quite powerful. The stubs is kind of where everything starts to go wrong, unfortunately. So Mockito kind of overloaded the term mock here to also mean a stub. So not only does your mock record the interactions in Mockito, but it also allows you to return the data. Now, this is good from a developer perspective because it means that's one less object that we need to create and pass in for our tests, which is nice. But the language becomes a little blurred when you're talking about your tests. Maybe if you're pairing with your coworker, one of you says mock when you mean a stub, so the reasoning might get a little confused there. But it still works. It's fine. So you just give it the mock and you say, hey, when this thing gets called, then return. So you have your responder stub. You can also throw your exceptions here. So if something goes wrong, just throw an exception so you have your saboteur. You can also use this for your test-driven development. So if you just have a interface for an object you're trying to create or some sort of role in your system you're trying to figure out, you can use the mock to create an instance of that object and then drive out the functionality in test. And once you have it figured out well enough, you just replace that interface with a concrete implementation. We move on to spies, and since Mockito did kind of overload those terms, we have mocks and stubs doing the same thing. The mock kind of functions as a spy a little bit because it takes those two roles. The only difference here is that you don't get any of the state access. So what happens when you call a mock like this, Mockito basically creates its own class for this particular type. And it fills out an empty implementation. So it returns whatever default value there are for the functions that you have. So this is technically sort of a mock, maybe. But Mockito actually also has spy objects. So there's a spy method that you can use. For this case, you have to pass in the real implementation of an object. So that's where the internal state comes from for the other part of a spy. So in this case, I'm spying on my attendee store. I can do the mock, or the stub stuff, where I say, hey, when you get this method called, return this value. You can also verify that certain methods were called on that spy. It's not shown here, but you can also query the spy for the internal state of that object as well. Dummies, Mockito doesn't have dummies. This is, again, where the mock kind of gets overloaded. You'll see this in tests from time to time, where it's like, hey, I need this object to fill a parameter list, but I don't want to go through creating the entire object. So I just make a mock and pass that in, but it's not really a mock, it's a dummy. So you can do that, but just make sure you name things appropriately. Last up, we have the fakes here. Now, Mockito doesn't have fakes. Reason for that is, again, they are actual Java or Kotlin implementations of some interface. So they're like a fake session store that stores everything in memory as opposed to in a database. So that kind of is outside the responsibility of the mocking library. All right, quick recap. So we've seen a lot of the terms used for test doubles. Now, you can continue to use the terms as things like Mockito and so forth do. Most people will probably understand what you're saying, but I have had a few communications here and there where using a more correct term for a test double would have made it clear what the test is actually doing. So I think the language that we use when describing our tests and what parameters we're passing in can kind of help clear up that confusion and make it more clear to your coworkers or to future you when you're looking at the test again, what exactly that test is doing. So just try to use the correct terms whenever you can. Also, be sure to match your test doubles to the appropriate tests. Don't use a fake in a unit test because that doesn't make a whole lot of sense. This is more of a concern when you get into the integration and end-to-end tests, particularly the end-to-end tests, just because if you start using a lot of mock objects in your end-to-end test, then I'm willing to bet money you're not actually testing what you think you're testing. You might as well just call it an integration test at that point and be done with it. And maybe the most important part here is do not overuse your test doubles. I've been bitten by this more than I would like to admit, but it's very easy when you're starting to build out a project, particularly when you're doing test-driven development, and just start using mocks and stubs and spies everywhere, and then you realize your tests are way overspecified. You're testing like the exact order that all of your functions and what have you are happening. So anytime you have to refactor something or change something, all of a sudden all of your tests are breaking and you feel just like deleting the test suite instead of actually going and fixing them. So just be careful with what kinds of test doubles you're using. Try not to use them too much here and there. Unit tests, they're fine because, again, keeping things separate. But that gets more into like integration tests and things like that. So just be a little careful. So last slide, who am I? Who's this guy talking about test doubles? Again, my name is Brian Gardner. You can see my Twitter handle on there. If you would like additional resources on test doubles, there are a lot of them. So Martin Fowler is a fantastic resource for test doubles. He's kind of one of the OG testing folks. He's got a lot of great blog posts. There's one I always go back to from like 2007 that he wrote, which is fantastic. Also, Gerard Mazzaros wrote an X-Unit testing patterns book. So if you want to know way more about testing than you probably ever wanted to know, you can go ahead and get that book. It's a great resource. Just a warning for you, it is basically a textbook. It reads like a textbook. I've only gotten like a quarter of the way through it because it's about that thick. So it's good for like bedtime reading if you're having a hard time falling asleep. But that is, again, a good resource if you have any more questions there. I work at a company called Big Nerd Ranch. Y'all might know us from our books and classes and things like that. So I might as well tell y'all a little bit about that. So we do consulting work. We write books, of course, and we teach classes. Pretty much covered that. We have a new Kotlin book out, so if you want to learn Kotlin, we have that. It actually finally shipped now, so that's happy. We're working on the next edition of our Android book, of which I'm one of the authors, so that's fun. Converting everything over to Kotlin, so be on the lookout for that, probably early next year. And yeah, so I can take any questions if you have them. All right. Well, thank you all so much for coming to my talk. If you have any questions, I'll be wandering around.